Welcome everyone. My name is Jacques Raubenheimer. I'll be introducing you to our team briefly. Dan and I were talking over lunch and we realized we probably can claim the title, seeing as this is a statistics conference, for the team of presenters with the greatest variance in where we come from. Because Dan is from Newcastle, so it took him an hour and 40 minutes by train. And I've come from Sydney, and we've got presenters from South Africa and India zooming in. Akshaya is from India, but he's in the US at the moment. So, so we've got a very international flavor and a very wide variance in distances for this presentation. Right, so I'm going to give you a short introduction, and we will then hand over. This session has been planned since 2018, and it's actually happened now after the pandemic. And a lot has changed since we actually pitched this to the RSS. At least two of our team have actually moved universities, and so there's a whole bunch of reasons why not everyone can be in the room, but we hope that all the technology makes everything work. Right, so just a word about Google. If we'd thought about this a little bit better...
Recording in progress.
All right. We would have asked the RSS if we could present this right at the beginning, because I think on the 3rd or the 4th of this week, Google had its 25th birthday. So Google was founded in 1998. Currently, as a kind of a worldwide average, it fields about 90% of internet searches, some countries more, some less. And you may be surprised to know that internet searching is still the number one internet activity around the world. If you count sending emails, that may actually outdo it, but you don't normally send emails through a browser unless you're patching in through something like Outlook Online or Gmail. But in terms of actual browser internet activity, internet searching is still the most common activity. All right, so this is just a bit of a timeline. I'm not going to talk you through the entire thing. So there were search engines before Google. You might have heard of Yahoo. And a lot of things have happened. I've tried to highlight some of the most important papers in terms of Google Trends research on this timeline. And of course, this is where we're at, and I'm being bold enough to say this is another step forward in terms of Google Trends research. So in terms of our team, we have these 5 presentations planned for you. So Akshaya is going to present on keyword selection. Herman is going to take that idea of keyword selection a little further and look at how we use Google Graph and different geographies. I'm going to talk about sampling in Google Trends. Dan is our visualization expert. He's going to look at analysis and visualization of Google Trends data. And then Amy Mavragani, her presentation, she also isn't able to be here, and I will be presenting her slides. Her slides will focus on reporting standards for Google Trends studies. Right, so between us as a team, we've got 33 papers, letters, or presentations on Google Trends, amongst others in these and other journals. So our first presenter is Akshaya. He is an associate professor of epidemiology with a focus on big data analytics in epidemiology and infodemiology. He works in public health and technology, and he's done some work with Google Trends tools. He's at North Dakota State University. Our second presenter is Herman Myburgh. He holds a master's in environmental sciences with a focus on microbial diversity, and his PhD was in nutritional genetics. Both of those were from the Northwest University in South Africa. He hosted the Africa Unit for he was hosted at the Africa Unit for Transdisciplinary Health Research for a postdoc. And there he saw the power of transdisciplinary research approaches to societal challenges in the African continent. He's currently a senior lecturer at the University of Johannesburg, where he heads the Metaverse Research Unit, which is focused on finding innovative applications of this emerging technology. He teaches biostatistics and research methodology at undergraduate level, and also supervises postgrads in various scientific domains. Right, then I will be presenting. I'm a senior lecturer in biostatistics at the University of Sydney. My focus is big data, methods in epidemiology and behavioral medicine, especially the analysis of linked data. I also created the Google Trends extraction tool and a sampling algorithm, which I will discuss in my presentation. Dan is from Newcastle University. He's an expert in visualization and data science and network and social media visualization and also dynamic data visualization. So Amy is a lecturer in computer science and mathematics at the University of Stirling. She's also the scientific editor of the Journal of Medicine and Internet Research. She's done a lot of work in the field of big data, public health surveillance, and infodemiology. You will see that she's done a major Google Trends systematic review and provided a methodological framework for Google Trends studies. So that's just an introduction to the team. I will hand over now to Akshaya, who's coming in through Zoom. Sorry, I just want to say one thing. We will do all the presentations and then have a panel discussion with questions at the end. So we'll just switch from one presentation to the next, and you are welcome to ask questions in person, or if you want to, put them in the app.
Hey, good afternoon, everyone. Can you see my slides?
Yes.
Oh, thank you. I'm Akshaya. I'm giving this lecture from Fargo, NDSU, in the United States. My presentation is more focusing on getting the receipt, what to include and what to avoid while you use Google Trends, and what are the pitfalls when they consider the studies of Google Trends in the recent studies. So let's go first with a small picture that's called Pan Labyrinth, which is very famous. And the phone always says that I have hundreds of names that only wind and trees can pronounce, which means that when you look into the Google receives large amount of keywords every day. So that means whatever we are writing something, so it will not directly provide the same answer. So when a person requests a query, it goes to the Google server. At the same time, the Google provides ranking based on the number of queries related to particular term. At the same time, goes to each website as a spider crawling and get the information. So the information which we are getting might be different for our location and the time and the population. If you experiment same keyword for a couple of days, you will understand that Google cannot give the same answer every time. So this is how the Google Trend data can be changed. So the Google Trend search use three type of things. One is terms, topics, and keywords. So generally, the term is a specific result of that occurs related to search volume matches with the query in a given language. So if the language changes, the search terms changes. For example, you can see that you can use the space or plus or in this condition. So I tried using like monkey plus pox or monkey or pox. Both are same. And at the same time, monkey pox can be written as monkey and pox. So the next one will be the topic. So topic is a collective information of all the terms with a specific or conceptually they are same in any language. So already defined, but these topics are being collected and specified by the Google. However, the keywords are entirely different. The keywords used by the Google are especially used for the advertisements to get more people to get attention of the public to use Google Ads and grasp information what they want. And this is not really useful for the researcher. However, it's useful for targeting audience to reach out the advertisements to different audience in the world. So this is how the tricky decide. I believe that this is specifically when you see the specific searches. So the searches are can be meaning with the and. So monkey and pox plus or monkey or pox or monkey minus pox. You can write without pox and quotations. However, we cannot use parentheses like we use in the research. So I tried experimenting these in the last May. Then you can see here the Google searched like Google Console can able to provide only 5 keywords that we can try at one time, starting from monkeypox, and I give a small space in the second time. And third one is keeping a quotations, and then monkey mpox, which was defined recently by the WHO, and monkey plus pox. You see, it behaved very differently. And if you can, the beauty here is that you can get the data from country or worldwide to particular region or the district. And also you can get the data starting from 2004 until the current. And the real-time data can be like every hour it can show. And however, the categories the Google Trends defined are more than 350 categories. So these categories are really weird because Google defines by its own, starting from health, technology, business, marketing, so different type of categories that they have. And finally, the Google Trends can provide data on web searches happening in images, YouTube, news, and also shopping. So when I look into the 5 keywords, the highest keyword was dominated by the monkeypox, monkey plus pox, which has shown very high amount of searches compared to none. So this is really surprising to me to see that am I really searching for monkey plus pox or monkeypox? So which keyword I have to use here? Then I went in depth to understand what is the differences occur at the regional level. Say, for example, I took the country as a specifically and 7 days, and when I use the same keywords like monkeypox, mpox with spaces and with quotations and plus symbols, so again it showed the same trend. So I see that monkey plus pox is really dominant. That it's suppressing all other keywords. So what I did then, I removed the monkey plus pox and started searching. Then you can see here that monkeypox and monkey space pox, and in the monkey space pox is the quotations and mpox. You can see here there's a quite dominant of monkeypox term than compared to all other are neutral. So interestingly here you can see here the monkeypox and monkeypox the quotations showed a similar trend. So next one, I experimented using monkey plus because this is dominant and compared with the recent change in the name from March 3 to 10 this year. Using these keywords, I see that monkey plus pox is complete dominant than mpox. So a slight change in a keyword can have a great impact on how you search the data, how you change the data. However, when you look into the topics, this until now I discussed to you about, I presented to you about the keywords, but when you see the topic level, I used monkeypox and mpox all putting together, and with mpox as a topic in the disease, you can see there is a quite variation that this is quite unusual to see all together of monkeypox keywords are dominating the topic. So the number of searches are literally very high, even in Australia. So when I look into the slides compared to that same scenario in past 6 months and kept the same trend on different scenarios worldwide, it gave a similar, but mpox, these all keywords, monkeypox plus mpox plus monkeypox. So this gave a similarly very dominant trend compared to all other which are consistently same. So this is interesting because monkeypox and mpox queries trick almost perfectly with the monkeypox query, meaning people almost always use those two words together in that order. And this may change as well. When you use monkey plus pox individually, the keywords may change compared to use as a compiling all the dominant keywords that they are getting the North Star. So how to find a keyword? The question here is that how you find a keyword. So one of the best possible way is using word stream is a good for finding keywords, although we cannot use topic queries for the Google Trends for that too. So, but when you use the monkeypox here, it gives that popularity of this word. Like for example, a term which is monkeypox that's highly popular of around 6 million. And it's how it shows because these are the keywords that the Google gives to market use the Google Trends. And another one is Wikidata. Wikidata is good for finding free base IDs, although that can find those by doing the topic search in the Google Trends as well. But however, you can see here, if you want to know about the mpox, when WHO defined monkeypox as mpox, it gives different languages. So to understand the topic concept, it can be good for you to use Wikidata as well. And finally, I am going to show you how a Google Health Trends API, when you use, until now we are using a free source database, but this API is specially designed for the researchers to get the data on different keywords that they want to do a research. So these are all in probability for 10 per million population. And you can see here, these are actual searches happening with different keywords. So for the keyword like monkeypox, the number of raw searches are around 259,000 during July 31st. And at the same time, when you see monkeypox and monkey plus pox, mpox, these are variations. So these searches, these data you cannot find in Google Trends portal, which is an open source. So perhaps we should also compare, we should see that how these keywords may change when you use API with the Google Trends sometime. And Jacques will discuss more about how to use this extension of API in Google Trends data. Finally, I would like to talk about the limitations of the recent publication. Mostly they discussed about the limitations of Google Trends because there is a lack of data quality. Lack of accuracy could become a significant problem in source of bias because you don't know which keywords are using and whether these keywords are accurately to your data. And sometimes parameter estimates that eventually would lead to misleading wrong decisions. And another publication has significantly indicated that using single data source or single time search engine may not be accurately provide the information of what actual searches means. So that means we need to collect a series of queries of related search volumes of the data and minimize the standard errors to have a consistent confidence interval threshold to attain the sustainable data that we want for the analysis. However, with related to the search terms and topic discrepancies, it is still not clear. None of the publications have been highlighted the disparities in the keywords in Google Trends. See, for example, you can see here, I made a small graph to show you that a monkeypox term and monkeypox topic and monkeypox as a topic has a significantly different way of data. So if someone considers these data as reliable and get published, that means we are really having a wrong data presenting in a high scientific journals. So what does all means that one side we need to keep working on finding the right keyword. Another thing, having a multiple samples to solve this puzzle and to find a North Star. And finally, I would like to talk about some of the recent publications focusing because of these limitations using Google Trend. People started to use Google Health Trends API, which is currently available to some researchers. And these are some of the recent publications that focusing on methodology of harnessing how to use Google Health Trends data and what are the changes in the Google Health Data API, how to perform and access the Google Health data, and what are the searches and birth control. They use some experiment on birth control in Louisiana and Mississippi. So these are some of the things that's going on the Google Trends, Google Health Trends using API. That's it from my presentation, and thank you for your attention. I'm looking forward for your questions.
Excellent. Thank you very much, Jacques, and thank you to the audience for having me today. So my name is Herman Myburgh. I'm from the University of Johannesburg, and I'll be going along the lines of what Akshaya just mentioned about keywords. And before we get there, it's a real pity that I couldn't be with you in Harrogate for this event. I was really looking forward to it. But now at least I can share a little bit of South Africa. And I've been really fortunate to live and work in one of the most beautiful countries in the world. And I know that's a very loaded statement to be making on an international platform, and especially so considering that I'm making this statement with absolutely no statistical evidence to back me up at the Royal Statistical Society event. But with our vast diversity and animal life and breathtaking nature scenes, it could be hard to argue that this statement is not true. Now, South Africa is home to 12 official languages. South African Sign Language has just been recognized as our 12th language. And navigating the South African language landscape can be very interesting. For instance, certain phrases are universal in a country. So words like yebo means yes, whether you're in the south of South Africa or way up in the north, that term remains exactly the same. How I use just too long a phrase, so we'll say how's it. And the term braai would roughly be translated to a barbecue, but with what most countries would consider a year's worth of meat. There are, however, some terms that are not translatable or even understandable. For instance, our motto is in the Ngam language, which is now largely considered to be an extinct language. The translation is diverse people unite. Or so I'm told from the Wikipedia page that I consulted during my preparation. It seems that, like, South Africa has this propensity for using extinct languages, as our previous motto was in the Latin phrase ex unitate virus. But language is truly an interesting phenomenon, and one should always consider the challenges of translations and differences in meaning across different languages. As an example, I'm a native Afrikaans speaker, and we use the term onderdeur to explain this poorly constructed 3D animation that I'm showing now. So we would say the cow walks onderdeur the bridge. The word onderdeur referring to the event as seen from our perspective, of the cow walking from one side to the other side of the bridge and doing so underneath said bridge. I've yet to find an easier way of translating this word onderdeur, and I'd welcome any suggestions that you might have. However, language is how most internet users communicate and interact online, especially where search engines are concerned. Now, together with this, Google dominates the global search traffic, apart from certain exceptions like China and North Korea, where access to the platform has been limited by governmental or other regulations. Billion times of a day, billions of users are met with that familiar empty box where they can type in whatever information they require. Therefore, if written language is such an essential part of our online engagement, this should surely also be a vital component of our study design as infodemiologists and individuals researching Google Trends. There should be a lot of thought placed in determining the right keywords to investigate. And like the previous speaker said, this is vital to the success of your study if you are ever going to do a Google Trends study. These data should answer the research question that you are looking at, and it should not merely be whatever you thought of. So you can only do if you understand the language and nuances of the users of Google. Now, I'm going to go through a couple of examples of how language can have a massive impact, and previous speaker also alluded to this. Now, for instance, you are currently based in the United Kingdom. And in the United Kingdom, the term football is used to indicate a popular game. And this is how the Google Trends results would look if you type in football. However, the rest of the world often refers to the game of football as soccer. And soccer comes out with a completely different trends result. So we need to be very careful in considering our keywords. Now, what was of particular interest for me in this instance is that a non-soccer playing country all of a sudden did a lot of searches for the term soccer around about here. And what I found is that in the UK, Soccer Aid 2023 was hosted on 11th of June, and that coincides with this peak that we see here. So having a knowledge about the language use of a country is vital to the success. Now, we can do something similar for the US, where we'll see that soccer has several peaks coming through, but it remains a relatively low volume of searches, whilst football gives you a completely different graph. So again, we cannot use terms interchangeably, and we need to make sure that this comes across in our research. Then there exists also the issue of countries where certain terms are used interchangeably. For instance, in South Africa, we use both terms to refer to the game of football, and the majority of South Africans would speak of soccer, but our official governing body is called the South African Football Association. So understanding the cultural linguistic aspects of search engine users remains an essential consideration for the research on the Google platform, Google Trends platform. Now, luckily, there are ways of searching for this, and one of my favorite ways of doing it is using Wikidata. Now, in the previous talk, you would have seen that the languages highlighted on the Wikidata page would have been in English and Hindi, because this page updates from where you are currently finding yourself. So if you are based in a different country, if you're based in the US, you might be getting English and Spanish. I'm based in South Africa, so I'm getting, for the term association, football, which translates to football or soccer or footy or football, into South African languages. So we've got Zulu, isiXhosa, Afrikaans coming through on this page, and that gives us an idea of how Google and other databases are structuring their data classification. Now, Google used Freebase IDs in the past. Freebase was a collaborative knowledge database that was acquired in 2010 by Google, and then it was retired again in 2016 and made publicly available on the Google Trends, on Wikidata. So one can still go and find these original Freebase IDs, and a Freebase ID would always start with with a /m/, and that then gets classified as a particular term. So in terms of what we're seeing here, the term /m/02VX4, that's the Freebase ID for the term soccer, or the game played with a black and white ball. And that would be in any of the official languages of the country that you are searching in. So it's a major benefit using the Freebase IDs as apart from using just the search term, because you can search for anything in any language and you'll know that it remains consistent. Now, Freebase was retired in 2016, and Google then shifted over to Google Knowledge Graph IDs, and these start with a G, referring to Google. So terms that existed prior to 2016 would often be associated with a Freebase ID. It would be the /m/, whilst newer terms, such as COVID-19, which is reflected on this slide, would not have a Freebase ID and would only have a Google Knowledge Graph ID. Now, these can be used either or on the Google platform, so you can use either a Google Knowledge Graph ID or the Freebase ID, and the Trends platform will give you the correct term back. So in conclusion, when dealing with search data, one needs to be mindful that these data were ultimately generated by a vast audience with differing opinions, cultural and linguistic identities. Search terms can often be ambiguous, and therefore the use of Freebase IDs and knowledge graph identifiers are preferred in your Google Trends research or Google Trends API research. And then if you ever find yourself in South Africa, another universal term that you can remember is the term buy a donkey, which sounds like buy a donkey, and that means thank you very much for your time.
Great. So thank you to Akshaya and Herman for their presentations. I think the takeaway message from what... Oh my goodness, sorry, let me just check. I think the setting has been made over here. That shouldn't be on. Let's try that again. So the takeaway from their presentations is that when doing Google Trends research, the actual keywords and topics you use make a huge difference in terms of the data you get. So I'm going to touch on another aspect of Google Trends research that I think has been a little overlooked and that I'm probably on a little bit of a crusade to try and change, and that's the issue of sampling. And I think the main point is that I'm generally of the opinion most people don't actually understand the nature of Google Trends data and so miss this issue. So why, just by way of introduction, why do we use Google Trends? So I'm not going to give an award for recognizing this photo. That's not a bunch of miscreants. It's the first Everest expedition of George Mallory. He's actually at your top right there. And when he was asked why climb Everest, he said famously, because it's there. And I kind of think most people who do Google Trends research feel the same about Google Trends data. Why use Google Trends data? Because it's there. But I want to try and move away from that conception. We shouldn't be using it just because it's a free, easy, quick way to access data. If you really want to understand why, you might want to do the effort of reading this book called Everybody Lies by Seth Stephens-Davidowitz. He worked as an intern at Google for, I think, half a year or a year. He's got fascinating stories about what people actually search for. He was given privileged access to Google Trends data. He could see things that we couldn't see, like the presumed sex of the person searching, the presumed age of the person searching, things like that. Some stories I can't repeat in a public forum. You'll have to repeat the book for that, but it's really a fascinating read. The point he makes is that people use Google pretty much as a confessional. In other words, they don't use Google to search for things, but as an expression of searching. In fact, he says that it's an expression of people's desires, wants, and beliefs. And that actually is a compelling reason to look at Google Trends data. Right, so there is an issue of normalization, and this is probably the most statistics you're going to see. I know this is a statistics conference, but nonetheless, Google tell us they can't guarantee the accuracy of the numbers. They do provide zeros in the data which need to be excluded, basically because we don't know what they mean. They don't mean there was no search volume, but rather that there were too few distinct searches to actually classify it. They tend to suppress those values for the sake of identifiability. So what exactly are the data? Google Trends data points are the probability of a short search session. My goodness, that's a tongue twister. So that's a few consecutive searches. In other words, if you search something and you search it again immediately because you forgot what the answer was, or you click on the back button after having followed a link, they don't count that as a second one. To satisfy the corresponding term restriction, that term restriction, in other words, is what Akshaya and Herman were talking about, the words, the prompts you type in Google. Given it was done in a restricted geography, in other words, the either country or region or sometimes even the city you're in, during the time represented by that data point. And it's expressed as a probability which they multiply by 10 million just to make it more readable, but it's a probability value. So in other words, a value between 0 and 1. However, because there are so many different things that people search for on Google, those probabilities are really, really small, so that's why they just multiply it by 10 million. So if you want it statistically, this is the formula they provide for that probability. And as you can see, it's the returned value at the time point corresponding to the term restriction in the relevant geography. For Google Trends web data, which I will explain in a moment, it's additionally scaled to a value between 0 to 100. The way they do that is they take in your time series the value with the highest probability, scale that to 100, and then express everything else relative to that. So probability half the size of that will get a value of 50. It's also rounded to the nearest integer, which is some information loss in that data as well. So if we compare the data sources, you would have heard Akshaya and Herman refer to this. There's essentially two data sources. The one is just through the website. That's the scale data, scaled to 100. The other one is that researchers can apply to Google for an API key and get then what is called Google Trends Extended for health data. There are some differences. I'm not going to unpack everything. The important thing is that the time scale differs between those two, and the scaling differs, and that's a massive difference actually if you look in terms of the quality of the data you get. Sadly, also in terms of publications, there are literally thousands of publications that have used the web data, which is technically the inferior data source, and really only a handful that have used the API data. It's just a lot harder to do because you've got to apply for the API key, you've got to actually write code to get data from it and then analyze it. All right, so what's the big issue with sampling? So firstly, for any Google Trends extraction, if you do a Google Trends query, Google actually samples about 10% of their data. Well, they're getting about 5 billion queries a day, so it's a little bit of a big ask for them to actually mine all their data and give you the results. So they extract about a 10% sample, but to reduce the load on their servers, they cache that extraction for 24 hours. So if you repeat the query, you just get the same results back. However, if you wait for 24 hours, you get a new sample with new values. This is well known. It has been reported by Google researchers themselves since the very early days of Google Trends. It does mean that if you want multiple samples, you have to get one new sample a day, which for some researchers apparently seems to be too much work. So you've got to wait a day and you'll get that little bit of variation. So is it a big deal? I mean, why not just get one sample and go with it? Because everyone says it's big data. We're taking a 10% sample from 5 billion searches across the world. Does it really matter? So do we just do what everyone else does? Most studies just use a single sample. Across 14 years of Google Trends research, I was able to find, and I've bolded the dates over there, 7 papers apart from my own that have used multiple samples of data. So is it really worth all the effort if there's only 7, well, if I count myself, the 8th researcher over the last decade or so that have done multiple samples? Or, by the way, Akshaya and Herman have also done studies with multiple samples. But should we really bother? So I did a thorough investigation on that. Now, I'm hoping this slide works. I've got to try and get this. So this is 100 samples of codeine searches in December, just to give you an idea. And the solid line is the mean of all those samples, and the 2 dashed lines are the 2 samples with respectively the highest and lowest values. This is, by the way, Google Trends extended data, and it's pretty much what we'd expect. Nobody's searching for codeine on Christmas Day. Most people are searching for codeine just before New Year. So it's totally plausible, but what I want you to realize is the big variation between some of those sample points. And this just highlights the issue that, yes, it does make a difference. What you get back from one sample to the next could be different. And I think I want to use this slide to illustrate the problem to you. Most people are used to time series data being complete data. If we have a time series of hospital admissions, for example, it's all hospital admissions. It's not a sample of hospital admissions. And so when we do something, for example, like outlier detection in a time series, we're actually looking for the time point that varies from the rest of the time series. With Google Trends data, because in that formula that I showed you, they are limited to a short search session, actually, literally, we have a sample of the data for every day in this series. In other words, you're not looking at 100 time series. You're looking at 100 time series consisting of 31 samples each, 1 sample per day. And so the outliers actually are not the outliers across the time series. The outliers are the outliers within the samples per day, because most people are actually only extracting one sample of data, they're just getting one sample per day. And that's where the issue lies. Most people have missed this fine point. So just to bring that home, this is again searches 100 samples for Facebook. The solid line is the mean and the band is the confidence interval around that. I haven't plotted all 100 samples the way I did in the previous slide, but the red line is just one sample compared to that. And you can see that that one sample is almost completely outside the 95% confidence interval for every day's sampling. So if you were the researcher who happened to draw that one red sample, you would be consistently underestimating the values in your research. If we take the samples and we actually compare the value by calculating the mean for one sample, the mean for two samples, the mean for three samples, we get this plot which you will probably recognize is very similar to what we see with the law of large numbers. Basically, it's telling us that the more samples we get, the better our estimate, and adding more samples gives us accuracy in a diminishing return. There's a point where adding more samples just increases the effort but doesn't really improve the estimate. So very briefly, this is work that I'm hoping to publish sometime within the next few months. What I did was I went and calculated how many values per time point in a particular time series actually lie outside of the 95% probability for that time point. Now, if it was perfect, we'd expect 5% for every time point. But as you can see, sometimes it looks pretty good. The solid line is the 5% value, but there is a lot of variation. So in some series, there can be reasonably big differences in terms of the number of time points that actually have what we would consider statistically abnormal values. Also, if we compare Google Trends web data to Google Trends extended data, this is an example of Google Trends web data, and you'll see that the percentages for the Google Trends web data, this is just for Australia, US, and worldwide searches for a range of terms, but you'll see that the percentages go up pretty high, and there are some time series which have over 70% and even close to 80% of their values being outside of what we would consider statistically probable values. Without doing multiple sampling, you just don't know. If we look at this previous one was Google Trends Extended, and you can see that most of them are around about 20%. And that's just the information loss that we have with the scaling and the rounding in Google Trends Web that exacerbates that problem. So, sampling, obviously we can see there's a need to sample because you get a better estimate when you sample, but doesn't make a difference in your actual results. So, in the good old days, I won't explain what I mean by that phrase, I had a Twitter API key and I had Firehose access to Twitter, and so I actually downloaded Twitter mentions for all these terms and downloaded the Google Trends data. I think this is, if I remember correctly, 2,000 samples of Google Trends data for every term, and I just correlated them. I said, let me do a simple, I could call it a simulation study, but a hypothetical study where I try and predict Twitter mentions by Google searches for the same things. These are correlation values, just simple Pearson correlations. The diamonds are the actual means, and you'll see that there are ranges over here. But if you look at this, you'll see that for some, for example, it's the difference between a correlation of 0.1 and 0.45. So in terms of Pearson correlation values, that's really big differences in your actual result. So yes, it can affect your results. Now, you will notice some of these have much bigger ranges and some have smaller ranges. I'll explain that in future slides. This is with Google Trends web data. Immediately you see, again, the quality of the data is better when we go to Google Trends Extended and the ranges are a lot smaller. So this is for daily and this is for monthly values, and you'll see there's slight differences which I will explain again. So where do these differences come down to? So here I plotted the coefficient of variation, firstly across time, and then again for all the different terms. And the thing I want you to see from these plots is that the early years of Google Trends data had a lot of variation and the later years much less. The simple explanation for that, I believe, is that Google was still growing. Google was founded in 1998, as I mentioned at the start, and they didn't have that size market share. And as their market share grew and the underlying user base grew, the actual estimates they were able to get got much better. So pretty much most Google Trends research using data before about 2008, 2009 probably doesn't look very good. I also noticed, and this is just comparing Australian, US, and worldwide searches for terms with low and high search probability, you will see that the variation is much higher for low search probability terms, and it's also much higher for Australia, which has a lower underlying population than for the US and worldwide. So in other words, this idea that Google Trends data is big data only goes so far, because if you're working with a small geographical region, suddenly you don't have that many people when you take down to 10% of the sample, which I will illustrate in another slide. I've also done some replication studies with students. So this is a student of mine where we looked at the results of one of the seminal Google Trends critique papers, and we tried to replicate their results. So the black line is their result, the grey lines are our 130 samples, and the red line is our mean, and we can see that it does make quite a bit of a difference. This is just another plot. So we're also hoping to publish this pretty soon, but you can see that it actually does make a difference. We actually replicated 4 different studies. So on these plots, the dotted orange line is the original study result using 1 sample, and the grey lines are our samples, and the black line is the mean of our samples. This is a different study. I'm very puzzled still by why our estimates so underestimate the 1 sample that these researchers had. We were able, using their data, to perfectly replicate everything. So we know it's not our coding. We just did the same coding to get the same results they had, and then we fed in our 100 samples, and we got a very consistent underestimate on that. This is just more plots from that paper. This is a study that was published this year. Somebody published a paper saying we shouldn't trust Google Trends research because, you know what, I did a search on one day, and then I did a search a couple of days later, and I found different results, and therefore it's not reliable data. And so I realized this person doesn't understand that Google's sampling their data, and I wrote a response. And the point I want to make here is that these 3 peaks are actually very important peaks for this particular person that the search was about. This was a person from Denmark, I think, Jacques. He was the head of their spy service. And again, you can see that variation in the first few years of data. And what this graph shows is this is using the mean of all the samples, and this is using the median. And the simple lesson is we should probably aggregate using the median, because if there's little variation, there's not much difference between using the mean and the median. But if there is a lot of variation, then the median's probably giving us the better estimate, which statistics 101, it should be pretty obvious. But this also highlights the point that we need multiple samples to actually get a stable estimate. You can see, especially for the early years, how widely these estimates varied. So what are the solutions, just by way of wrapping things up? So the first thing I did was I developed a sampling algorithm that allowed us, using the API with the Google Trends extended data, to theoretically get upwards of 2,500 samples a day. I found basically a sneaky way around Google's caching problem, which was to break the time series up into its components, sample each one of them, and then reconstitute the samples into the smaller ones into big complete samples, which differed. Unfortunately, Google made this. I was published last year in AJE, and I don't think it was because of my publication, but purely coincidentally, about that time, Google made a change to their data, and this algorithm doesn't work anymore now. We're back to 1 sample a day. I also built an extraction tool which runs in Excel. It allows researchers to actually access Google Trends extended data without having to actually do any coding. They can just type in their parameters and it will extract samples for them. The work I'm currently doing is, so the big question is, how many samples do we need? It's complicated by the fact that it depends on how many time points we have. And remember, we're actually, every time point you need to sample multiple times. So I'd love to hear opinions on this, but essentially what I'm trying to do now is say, how many samples do we need to make sure that, for example, 80% of our time points have probable values within what we would consider to be the 95% confidence intervals, or how many samples do we need to get 95% of our time points or 99% of our time points. So I'm trying to work on that with a whole bunch of samples, and I've got some algorithms that kind of can calculate that and spit that out for your data. It does mean that you have to download a couple of samples to get an idea of what is the coefficient of variation in your data, and then you can estimate how well you're doing, how much variability is there in the data, and then you can try and get an estimate of what would be a good number of samples. So that's still work in progress. Watch this space. So just in terms of some closing recommendations, unfortunately we're back to a sample a day, but we should be doing multiple samples. We should sample according to the nature of the study. I showed you the formula for what Google Trends says the value is. If it's a term that we think has low probability, we should sample more. If the time frame is older, where there's more variation, we should sample more. If the geography is small, like Denmark, then we should sample more. So if the underlying population size is small, and we should probably use the median for all the time points across all our samples. So I'd just like to thank Nick Buckley, my boss, who actually gave me permission to do all this work, even though it was only tangentially related to what he really wants me to do. It has had some value for his program. I'd like to thank all the students who've worked under me on some of these questions, various collaborators, some of whom are presenting here, users who gave feedback to my tool. In the early days, Google Trends staff gave me some very valuable feedback, and of course Google for making the tool available. So with that done, I will hand over to Dan. Oh yes, and thank you to RSS for hosting this session. So I'll hand over to Dan now, and then afterwards I will do Amy's presentation.
There. Oh, Control L. Okay. Right. Hello, everyone. Welcome to the fourth presentation of the session. And now for something completely different. I'm going to be mostly speaking about a property of data that is frequently in Google Trends data, and what we can do to make sure that we're visualizing it properly and better. So let's start with a simple question. Well, may not be simple. Depends on your artistic perspective of these images. Which image looks better? The one on the left or the one on the right? Who thinks it's the one on the left? Raise your hand. Who thinks it's the one on the right? Yes, that's what I thought. It does look a little bit clearer now, doesn't it? Now I got a second question here. Which image is the original? Okay, who thinks the original image is the one on the left? Who thinks the original image is the one on the right? Haha, I fooled you. So, of course, the one on the right is better. But the one on the right was derived from the one on the left. So if you look at the grayscale values on the one on the left, you see nothing happens for a little while, spikes, nothing happens for a little while, right? Whereas the one on the right, what we've done is we've applied an algorithm called histogram equalization. It's used in image processing. And essentially what this does is it spreads out the events throughout the entire black to white spectrum here. So when a world event happens and people start searching, I think we're in the situation on the left, aren't we? And if you're visualizing your data such that you're using equal time intervals, You're looking at the gray image. So perhaps when we have certain world events and that sort of thing, perhaps we need to process these events in intelligent ways so that our visualizations can be much clearer. So we're in a situation when we have Google Trends data, where you have searches and that sort of stuff, where we have a non-uniform distribution of information, so it doesn't really make sense to visualize it in a uniform way. So in the previous images, we had pixel values, and it was non-uniform, and this caused the gray appearance to the image. And we used, as I mentioned, this process called histogram equalization, which spread these values over the space. Does this look familiar? Yes. In certain cases, it kind of looks similar to Google Trends data. So for the search data, there's a temporal resolution down to the second, and you could visualize it down to the second, but then you suffer from overplotting. You have too much information per pixel, so you can't see it. So what do? Well, you bin stuff, right? You aggregate your data. And normally, in the visualization community, and perhaps in the RSS community again, quite frequently, you just say, okay, we're going to bin things on a daily basis. So each day is going to have its own bin. Okay? If you do that, you have the gray image. So what I'm advocating here is you transform your data such that when there's little activity, you speed up time. When there's lots of activity, you slow down time and you do your binning that way, at least for visualization. And the main reason behind this is, when we have a situation of a world incident happening, there's some drastic changes. Everybody starts searching, there's a spike. We need to really devote more of our space in the visualization to that spike to see what's going on in there. Okay. So I'll give you a little bit of an example. So with Google Trends data, we could have had search terms and that sort of stuff. I'm going to give you an example with graphs. Why am I going to give you an example with graphs? Because I've worked a lot on them. And then I'll come back to the Google Trends data. So up until 2017, when we drew animated pictures of graphs, what we would do is we would sample it on a daily, weekly basis, take that time, compress it down, because we can't look at the original resolution because there's going to be overplotting. And then you draw the set of time slices together to get an animation or look at the individual graphs over those time periods. Part of our work essentially said, no, we shouldn't be imposing the binning on the data. What we should be doing is we should have the data determine what the binning should be. So if you have a spike in the data, the algorithm will actually introduce more complexity into the visualization around that area. And if nothing happens, it will remain this long, straight line. And the way that we do this, I don't know if you know anything about force-directed algorithms, where force-directed algorithms are a way of drawing networks. You have nodes and edges. Two nodes repel each other if they get too close, and an edge acts as a spring to haul it together. You can repeat this process in a three-dimensional space-time cube, and that's what we're doing here. And now your nodes are these lines. They're sort of like spaghetti strings, and the edges are surfaces. So the strings sort of push each other apart, and the surfaces actually bring them together without going through all of these geometric particularities. Okay, so then you'll have this cube, and as the neat part about this cube is we haven't imposed any sampling on it. So we haven't imposed, for visualization, a binning into equal time equal time intervals. So you could, or one could think that you could just look at this cube directly. There's a bunch of perceptual and psychological research that if the item is not actually inherently 3D, people have problems understanding this in visualization. So it's probably better to go and look at some two-dimensional visualizations. Part of my work earlier in my career demonstrated that animations actually might not be good for this. And we can have a longer discussion about that. The main reason, the intuition they'll give behind you, when you're doing analysis using an animation, you need to memorize the early part of the video to compare it to the later part of the video. So it's now a memory task versus moving your eyes. Okay? So animation's not that great, or for certain tasks it's not that great. I need to be a little bit careful there. There are some tasks it's quite good for. So how should we actually present this? Well, what you can do is you can actually present sort of like a comic book of your data. So just like a standard comic book, you can read it left to right. In this case, we have a uniform time slicing of the data. This is a graph derived from tweets around the Guinness Pro 12 rugby competition. In the first part up here, of course I can't use my mouse. In the first part up here, we've decided to do equal time slicings, and there's a fair bit of variability among the events. You can see that some of these time slices have no information at all, and others have way too much overplotting. The advantage of this visualization is one of these comic book frames represents the exact same period of time. The main disadvantage is a lot of your data is hidden by overplotting here. But by applying a version of histogram equalization across time, you notice there's more visual complexity here, more uniform visual complexity here, meaning that we've taken away some of the overplotting in some of the later frames and put it into some of the earlier frames. The advantage of this is now you can actually begin to see some of your data. The disadvantage is now your frame could be several days, weeks, or half an hour. And you need to use different visualization methods in order to demonstrate how fast time is passing or how slow it is. So back to Google Trends data. So Google Trends data does come at multiple resolutions, and you do have temporal resolution down to the second. Often when we analyze this, it's done at a particular resolution. You choose a resolution, you do that. What I'm advocating, at least for visualization, is when activity is low, you take wider time samples and you do your visualization that way. And when it's high, you do finer. And the main reason why we need to do this is both screen resolution and overplotting. Okay? And also, if you decide to do this, you need to remember to visually indicate how fast we're going. For this period of time, is it half an hour or is it a week? So, as we can see here, when we have this situation in Google Trends, we would like our sampling for visualization purposes to sort of adjust itself to the data, because otherwise we are looking at gray images. Thank you very much.
Right, so now we move to Dr. Mavrogani's presentation, which will focus on some examples to demonstrate best practice in the actual reporting of Google Trends studies. So just by way of introduction, there's various ways that we can look at public preferences, such as traditional surveys, and in recent days, researchers have tried to find more novel ways. Since we're in the 21st century, we've turned to internet data. So we've looked at social media data, internet discussion forums, and of course Google Trends data. I can mention that there are other search engines out there that have been used in studies, notably China's Baidu, but by far the majority of these kinds of publications have been Google Trends studies. So there's a wide range of research fields that have used Google Trends data. The second most common, I think, is economics. The most common is definitely public health. And it's given rise to the terms infodemiology and infovalence, which we will return to. And we need to be very careful of thinking that everything can be predicted by Google Trends. I would actually go a little further than what Dr. Mavragani is saying here and say that we should place less emphasis on using Google Trends to predict and rather use Google Trends to understand. So some examples, these are some of her studies that I will just present to you briefly. So she did a paper in which she explored the role of non-pharmaceutical interventions, which is a much less controversial term than lockdowns, in flattening the Greek COVID transmission curve. They used a large number of predictor variables with two models. One looked at daily cases and another at daily deaths. Their predictors were active cases, recovered cases, and for the deaths model, daily cases. And they included a term for the lockdown in the time periods. They used an auto-regressive model with bootstrapped estimates and found that the best lagged effect for the NPIs was 7 days. Now, relevant to this presentation is that they ended up not using the Google Trends data in their final model because it didn't actually fit well. The next example, they actually looked at Google Trends searches in the early days in the US. This was actually submitted on the 27th of April, 2020. And they used a quantile regression approach, and they noted that although significant correlations between COVID-19 and Google data were observed, that relationship tended to decrease in strength and significance in regions that had been affected by COVID-19 as they moved forward in time. And I suspect that actually what was happening there was that most of the COVID searches on Google were driven by media interest rather than actual symptoms of COVID, if I can put it that way. More work that she has done was predicting referendum results. So during the 2015 referendum, she and a colleague did a study where they downloaded real-time Google Trends data in hourly, 8-minute and 1-minute resolutions. They didn't download it every 1 minute, but Google can give you that time resolution. And their estimates put the no vote at somewhere between 56 and 58.2%. The actual outcome was 61.3%, so not too bad as a prediction. In a second paper, they actually did that, they repeated that with 6 other European referendums, and they were able to predict ex post facto those referendum results with an accuracy anything between 0.1%, which is very accurate, and 5.7%, which is still not too bad. I actually built on that. In 2020, I modified their approach a little bit and performed what I believe to be the first truly prospective prediction of a referendum using Google Trends data. So New Zealand had a referendum on the legalization of cannabis on the 17th of October, and their preliminary results were released on the 30th of October. We submitted this paper to the journal on the 23rd of October, putting our necks on the block, as it were, with our prediction. So as you can see, there was some uptick in search interest for the referendum beforehand. This was a good stress test because there was an election on the go and 2 referendums, one on cannabis and one on euthanasia. So we had to think back to what Herman and Akshaya were presenting. We had to choose keywords and terms that could disambiguate between the different referendums. So it was a good stress test, and just by way of summary, I used different time scales, daily and hourly, and different ways of accessing the Google Trends data. The bolded values, we wanted to come within 2% of the actual outcome. The bolded values are the ones that did that. In fact, our final result using the daily data was with 0.3% within the actual referendum result. So we outperformed the polls with our predictions. So that was pretty neat. Another example is that she looked with a colleague at predicting UK pound exchange rates, specifically UK pound to US dollar and to euro. And they used both UK and worldwide searches for pound and euro or dollar search terms, as well as pound sterling as a topic. Think of those Freebase IDs and Google Knowledge Graph terms. And they used a quartile dependence method to test for directional predictability from Google Trends data to the pound's exchange results. I won't show you the results table. It's quite long. It's summarized also in that plot, which I'm sure you can't see. But nonetheless, some of the lags were significant and some were not. So bit of a mixed bag in terms of actually being able to predict that. So coming to the idea of infodemiology and infovalence, infodemiology was coined by Gunther Eisenbach in 2009 as the science of distribution and determinants of information in an electronic medium, specifically the internet, or in a population, with the aim of informing public health and policy. So the concept of infovalence basically refers to using that internet data for epidemiological surveillance, and Google Trends has been used a lot in this. There have been 2 systematic reviews. The first one was by Nuti et al. In 2014. They focused on Google Trends in healthcare, including 70 studies, and they gave a whole bunch of recommendations that really only focused on providing the full query specification you used in your study, so with the aim of repeatability. They acknowledged that there was more to do, so they said this checklist that they gave is a good step forward to improve reproducibility of results by researchers, but there are larger limitations in the Google Trends tool itself. Building on their work, Mavragani and her colleagues did a systematic review in 2018 with 109 studies. They didn't really build on the recommendations, but they did do a good job of cataloging the different methods that researchers used, the different approaches in the analysis. So they listed methods for adjusting for seasonality, what type of correlations were used, the use of forecasting and statistical modeling, which tests and tools were used. The general procedure they delineated was obtain the Google Trends data, detect seasonality, detect whether seasonality is present, compare the search data with a comparator that you're using, whatever it could be, and then possibly use that to predict or nowcast or forecast the comparator. A year later, she published a methodological framework that was focused on Google Trends web data, and Zepecki et al. Published a methodological framework for the Google Trends extended data, in other words, the API data, in 2020. So I'm going to give you those recommendations from both of those studies, together with some that I've taken the liberty of adding, seeing as I modified her slides slightly. And I just want to run you through those. So firstly, I want to recommend that all studies, at least those in health, use the Google Trends extended data and avoid the Google Trends web data. Researchers in other areas might not be given an API key, so then they will have to use Google Trends web data. But the data just is of a much better quality, and that should be enough motive to use it. Secondly, I want to be bold and say we have to get multiple samples of data. If I really could, I would just say that journal editors should just desk reject any Google Trends study that uses one sample. Unfortunately, I can't say that to journal editors, but really we should only be accepting papers that have aggregated multiple samples of data. So we've said a lot about keyword selection. We really need to pay a lot of attention to keyword selection. I refer back to the earlier presentations on that. We need to decide whether we want to delimit scope in categories. So that's important. Sometimes we need to do that because those categories will allow us to distinguish between, for example, the cold as a disease versus cold as a weather phenomenon. Google Trends Web allows us to do that. The API, unfortunately, doesn't allow us to do that. So Mavragani highlighted the importance of choosing a time frame that is suitable to your comparative data. We also need to pay attention to the date resolution, which Dan was talking about. Unfortunately, in Google Trends Web, the time frame you specify determines the time resolution you get back, but with the API, you can actually request a time resolution. We also need to choose our regions carefully to match the comparator data that we're using, and we need to think about search properties, again, that you can only do with Google Trends Web, And normally you just do all web searches, but as Akshaya mentioned, you could look at YouTube, news, shopping, or image searches. Also, we should publish data if possible. Sometimes that's not possible. We need to look for seasonality and adjust for it if it's detected. We need to state clearly the analysis methods we chose and the reasons for choosing them. And then everyone knows correlation does not equal causation, and I don't think there's any researcher out there that thinks Google Trends searches cause whatever their comparator is. The problem I have is that a lot of researchers tend to think that correlation equals prediction, and it does not. And I think so. A lot of Google Trends studies just show we found a correlation between Google Trends and something else, and therefore we believe Google Trends can predict this. No, it can't. That's just a correlation. Correlation doesn't equal prediction. So really, if you want to do prediction, you should be using out-of-time period data to actually validate your prediction. Or you should take the data you have and split it into training data and a validation data set that you can use after having done multiple samples. And that's probably one of the things that most Google Trends studies fall foul of. So I am wrapping up. Google Trends data has a bunch of limitations. The sample is unknown, and we don't know the underlying demographic factors such as age or sex. So just think, for example, Google searches for breast cancer. How do we know how many of those were actually done by males or females? We can't know. We should be careful about the analysis that we perform so that news reporting doesn't affect that. In fact, I think most Google Trends peaks are driven by media interest. And of course, the Google Trends choice of keywords is very important. So the Google Trends flu incident she is referring to is that paper by Laser that I was showing previously, where they basically showed the original Google Trends paper fall foul of dimensionality, where they basically just did a big machine learning exercise to find all terms that correlated with flu and chose those to build their model. But a lot of them were actually spurious. So, whether we like it or not, Google Trends data are being used increasingly for public research. We need real-time data, and I think that's why people are using Google Trends data. And it does give us some value. I would argue less value for prediction, more value for understanding. So just some papers that she's used for this presentation. So sorry, I see we are slightly on time. So I'm not going to force you to stay for questions, but we do have Akshaya and Herman, so if we could switch to them. And if anyone wants to stay a bit longer, I'm volunteering Dan and myself and our other two presenters to answer any questions. If you are in a rush to go somewhere, I won't force you to stay. So you're welcome to leave as well.
Testing.
Yep.
Does that do anything? Okay. This actually probably is mostly aimed towards yourself, Jacques. So you mentioned about the different search engines, and that Google Trends is probably the best of them. But I was wondering if there is any value in sort of aggregating across different search engines in order to increase your sample sizes, and whether or not there's any sort of inherent population differences or biases across those different search engines.
So firstly, Baidu has a tool that's similar to Google Trends. Bing doesn't. There have been some studies, but those researchers have typically reached out to Microsoft, and Microsoft has made data available to them. So that probably the big reason everyone uses Google Trends is there are tools to do it. And Chinese researchers use Baidu. So I would be careful though again, because the whole point of all the variability in the data is we actually need a massive underlying user base if we're sampling the data to get a good estimate. If we were using a service that had only 5% of the population of searches and we were using all their data, I probably think we'd get a reasonable estimate. But we also have to think about what kind of user, isn't there a difference in the user base? So there could be, it's the old thing of digital equity. There could be important differences in the underlying populations that use different search engines. So that's also something we would have to consider. In terms, and then to actually address your question, I don't think we can actually compare across search engines, because even the Google Trends data is a probability of the search being done on that day in that region. And I don't know, for example, the Microsoft Bing studies, I can't recall exactly, but I think theirs was basically the volume of searches. So it's even expressed differently, and we'd have to try and reconcile that. Mm-hmm. Yes, sorry, we have to do this, otherwise they can't hear.
Hey, yeah. Thanks for sharing. I'm just wondering about this once a day sampling, because Google stores the archives or cache the search, right? Whether we can sort of hack it by using the OR operator. So meaning to say, if I am interested in monkeypox, I can search for monkeypox, and then monkeypox plus some ridiculous phrase like R, which will not have people searching monkeypox and this. It will be a null kind of thing. And therefore, essentially, you are searching for monkeypox again, but it's a separate sample. And therefore, if you try to hack it this way, then you can actually get all your 10 or 100 samples at the same time, instead of having to wait a day for each sample. Yeah, I'm wondering whether this will be helpful and it's possible.
Can I answer this? Yeah, I like the suggestion. Search for monkeypox and Caltex oil. Nobody's going to search for those two together and search for monkeypox and tissues, or I don't know. Yep, so good suggestion. Maybe, yeah, so if you just throw in spurious terms that aren't going to appear, we'd have to try it and see. So, Herman, Akshaya, we've got some homework to do. Yeah. Yes.
Really nice presentation. Let's say you wanted to understand something in a country where maybe your sample size is going to be low. So let's say you want to understand conflict in a certain country, and is there a way you would recommend, such as, for example, you search for terms of conflict or whatever extra terms you are interested in that specific country, and let's say you also search worldwide, and then basically created some sort of like multiplicative model of the two trends, or do you know what I mean? What I'm getting at, it's like what are the methods that you might suggest to get around this low sample size, noting that things might have a national context, but equally might well correlate on a worldwide basis if you don't have the numbers to meet it.
I'm going to ask Herman and Akshaya to answer that question. Herman, will you go first, and Akshaya, will you follow him up?
Thanks, yeah. So it's indeed a very interesting question, and one we need to think about how to do that. In my opinion, I think you've hit the nail on the head. You can do it in that way where you compare different countries. If you're using the Google Trends extended version, the API, then you can do comparisons between countries. If you're just using the online trends, that becomes a very difficult concept, because the RSVs are based off of the number of searches. So I'd suggest with Trends API, you can certainly start investigating it. But yeah, Akshaya, what's your opinion? You're on mute.
Thank you, Herman. Yes, thanks for this question. I spent my whole 2022 working on this to see how a sample or Google Trends respond when you have a low population level or with high population level, comparing them. So I ended up with no answer. It's really very difficult, because when you're interpreting the Google Trends data, it depends upon the time you search and the number of population and at the location, geographical location of the place where you are staying. So it's very diverse to see. Sometimes if you may get a sample of 100 today as a North Star, which is reaching the highest peak, but tomorrow when you say, the dates will change, because always every 24 hours, the Google will calibrate its data. So with with less population, and when you want to compare, you don't get any normalized value, even if you get a 200 sample, and you cannot get normalized because the population changes and calibration changes and the data changes. So I tried of comparing the United States with the low population or states with the less population with the population, the higher population like California with the Maine or Dakota. I find nothing. This is completely changing all the time. So that's very difficult to find in the Google. Second thing is that, always when you're looking the data and we see that, okay, Google Trends data, but Google Trends data interpretation is entirely different than what we see. It always looks into the population level, the number of people per 1 million and the number of searches. So we ignore the population, then we go with the time. So if you search in the morning time at UTC, that will interpret differently. If you search at the night time, the results will be different. So it's very difficult for the Google Trends also to analyze that at what time I'm taking the data, whether I have to take in the morning, night, or I have to spend my whole 24 hours checking on which day, which is the absolute time I need to search the data. And final thing is location. So it depends upon the states with the population and geography and your country population and number of searches to that population. And it's still like a black hole that we don't know how Google Trend calibrates this data to a particular region or population. So that's generalizability to the worldwide. It's really very tough. Thank you for asking this question.
Perhaps I can just add on there. In using this API, normally when you're using an API, you've got a lot of information available, how to use it, and that's unfortunately not the case. It's very limited. So we've been given this wonderful tool, and they basically telling us go and explore it, and that's why people like Jacques' work is so important in trying to get to terms what exactly we need to be doing with Google Trends.
Wonderful.
Any questions about Dan's visualization presentation?
It's okay, I know I'm an oddball.
All right, well, if there's no further questions, thank you everyone for coming. I know this is the graveyard shift of the conference, but you've done really well to stick with us through it, and I appreciate your coming.
Thank you.